Hello, my name is Jerry Gajunas, and today we will be going over biomechanical applications to orthopedics. If you've already seen my first video on this, I discussed how biomechanics refers to the study of mechanical laws pertaining to the human body. Between biomechanics and orthopedics, there are many overlapping topics that can be discussed in further detail. Today's question refers to the stress-strain curve commonly seen in biomechanics. The question is, in the stress-strain curve, irreversible change in length after removing the load during the plastic range is called blank. Our answer choices are elastic limit, proportional limit, breaking point, ultimate strength, and plastic deformation. When analyzing the stress-strain curve, we can identify the section the question is referring to as this curved section right here. Now, the elastic limit, the first answer choice, is the point of elasticity right before this curved section. So this is not our answer. The proportional limit is very similar to the elastic limit and refers to the yellow right there as well. Also not our answer. The breaking point refers to where the material actually fractures over here and the curve ends up stopping. While this is irreversible damage, it refers to a different action that's occurring, so it's not our answer as well. Ultimate strength is the top of this curve, as you can see right here, where the material can experience the most load. This is not our answer, but this only leaves plastic deformation left. And yes, the answer to our question is plastic deformation, which is the permanent deformation that occurs when a material has been subjected to a load such as bending, tension, or compression. To dive a little deeper into this topic, let's define what the opposite refers to, or elastic deformation. Elastic deformation is deformation that returns to its original shape without any permanent damage, just like stretching a rubber band and having it return to its original shape. This is elastic deformation. It can be seen by the linear part of the stress-strain curve right here. This is the elastic region. Right at the point where the linear section ends and begins, this curve is the plastic region right here, and we call this the yield point or the elastic limit, the proportional limit. After this point, the material will experience plastic deformation in this curve and not return back to its original shape. Now, let's talk about why this matters in orthopedics. In orthopedics, understanding the characteristics of the body and the materials already present in the body is very important. When performing surgery, subjecting too much stress onto a material may cause plastic deformation. This would result in irreversible damage leading to complications and potentially more surgery. At all costs, it's important to understand these stresses and avoid plastic deformation. Also, understanding where plastic deformation begins for specific biomedical implants can help determine if the material will be suitable for its designated use. Plastic deformation may compromise the integrity of a biomedical implant if not thought of correctly. An example of plastic deformation occurring during an injury in the body is in the bone of pediatric patients. The bone is still developing when children are young, so they are not as strong as adult bones. Because of this, if a large enough load or stress is applied to the bone, it may become deformed. The bone in pediatric patients is a bit more ductile, so it can undergo that bending, that plastic deformation, or the bowing shape like you can see in the image right there. If the bone were more fully formed and brittle, it would likely just result in fracture or the end of that curve, if you remember the stress-strain curve. One method for fixing such an injury involves osteotomy, which is the cutting of bone. Surgery is performed to cut the bone and return it back to its original shape, as you can see in the image right there. A metal plate will then be used and inserted to keep the bone secured at its new place and allow it to heal correctly. The bone will not be able to return back to its original shape, however, because it underwent that plastic deformation by itself. So it's important to understand plastic deformation and how it can affect different parts and different materials of the body. To restate the question, in the stress strain curve, irreversible change in length after removing the load during plastic range is called plastic deformation. Thank you for listening, and I hope you learned something.